Let us continue with our study of improper integrals. Now we saw that there are two kinds of improper integrals. There are integrals that involve infinite limits. Something like this. And the integrand is well defined. Over the interval you are integrating from 1 to infinity. That is to say, 1 over x squared is well defined for any value of x between 1 and infinity. So the impropriety comes from integrating up to infinity. The second, integrals where the integrand becomes undefined. Over the interval of integration. So an example of that would be something like this. You can integrate 1 over x squared, but you can integrate over a finite bound, say from 1 to minus 1. And the impropriety comes here from the fact that you're integrating from minus 1 to 1, inclusive of all numbers in between, with 0 also. And when your x is 0, your integrand is undefined. So say if you look at this graph, this function 1 over x squared. So the first integral would be this one here. And the second one would be this one here. In some sense, you can say, well, they're talking here about a horizontal aspect here, they're talking about a vertical aspect. Now, the way to approach this is to say, well, integrate up to some finite number a. Integrate up to some finite number a. Then you will pick up a function of a. And then on that function, let a go to infinity. This is a proper integral, provided a is finite. But then you let a go to infinity. You don't let a go to infinity here. You let a go to infinity after you go down. That is to say, after you do your antiderivatives, and after you evaluate the antiderivative at a at 1, subtract, then you will find a function of a, and then you let a go to infinity. But you don't let a go to infinity here. How would so that is to say, you will integrate up to some number a, finite, and then you will let a go to infinity. So you find the finite derivative corresponding to the integral up to a. And then let a go. How about this one? How would you approach this one? And you want to find this integral here.
Like break up the integral?
How would you break this integral?
You could do 1 to 0 and 0, or -1 to 0 and then 0 to 1.
So you would say you could break it up as the integral from -1 to 0, and then from 0 to 1. But this would be an improper integral.
As a approaches 0.
Because so if you were to break it up into two integrals, and then down the next. But this is an improper integral because you're integrating all the way up to 0. And 0 is not allowed in the integrand. So you would, yes, you would approach 0. You would integrate from -1, but not up to 0, but some number slightly. Not 0. Less than 0. That is, you will approach 0 from the left. So you will integrate from -1 up to some number a close to 0 but smaller than 0, and then go to 0. Let's see. Let a go to 0 from the left. And then the same here. You would integrate from 1 to some number a, which would be some number slightly bigger than a, 0. And then let a approach 0, but from the right. So this would be this situation here. You put an a here. And here you put an a here. You would approach 0 from the right. That is to say, you will find the antiderivative of 1 over x squared, evaluated at a, evaluated at -1, so it will be a function of a. On that function, you approach a from, you approach 0 with a from the left. Here you will find the antiderivative of 1 over x squared, evaluated at 1, evaluated at a, and then on that function of a, you would let a go to 0, but from the right. Okay, so let us do some examples. Now we saw 1 over x squared last time, right? You can integrate or not? We saw that this was an improper integral.
Yeah, we need more on it.
1 over x squared from 1 to infinity. Well, you say, well, it's an improper integral, so you integrate up to some finite number a. And then you let a go to infinity. So this is just a calculus 1 problem. It's a function of a. Minus 1 over x. You evaluate it at a, you evaluate it at 1, and then you let a go to infinity. And so you will say, well, this is -1 over a minus -1 over 1. And then on this function of a, you let a go to infinity. This is plus 1 times 1 over a. And as a goes to infinity, this one goes to 1 over x as x goes to infinity. 1 over x as x goes to infinity. 1 over x as x goes to infinity is 0. So this number is 1. We say this is a convergent improper integral. That is, it turns out to be finite. This is a very important calculation. Extremely important. Now what happens, let's do the same with another function. How about, something like this? What do you try this one? Or did we do this one last time? No. Do it. So it involves finding the antiderivative, evaluating the antiderivative at a, evaluating it at 1, subtracting, and then letting a go to infinity. A very important calculation also. Extremely important. Now, this is very important from a conceptual point of view. This says that if you take the area under 1 over x squared and you go from 1 to infinity, that area is actually 1, no more. Even though you are integrating to infinity. And keep in mind that infinity is a very scary thing. Not many people understand what infinity is. Miss Lee, what is your question?
Oh no, I was just trying to read there what it says. Where it says -1/1 equals the middle.
So do you take the antiderivative, is this?
Yeah.
Evaluate it at a, evaluate it at 1, subtract. Yeah, and then let a go to infinity.